Welcome, Jose. Thank you for joining us today. I know everyone in the community is super psyched about this whole week. It's going to be one of the greatest weeks, hopefully, I've ever for Qubic. And we thought it was a great, apt time to have you on discussing your work with Qubic. I'll ask you some questions from our perspective, then I'll ask you some from the community as well. And hopefully, it should take about 20 minutes. So, how are you doing today, anyway, Jose? Are you good?
Fine. I was wondering and looking for meeting you, and we are here, so ready to start and to be with you and with the Cubic people.
Excellent. So the first question is going to be, can you share a bit about your journey in neuroscience and biotechnology and how it led you to Qubic?
hmm Well, I was since I was very young. Of course, I was interested in science, but I love to think about the future of things. So I first studied engineering, and then I had the opportunity to study biotechnology, and I was very interested in genes and what can we do in the future with genes for forecasting, for weather, for oceans, for microorganisms. But my background comes from the asking myself about the mind, and then I moved to neuroscience, and I love how the brain integrates reason and emotion, and how the brain is the organ in which the outside world, the inner world, and the body world merge together. So since that time, since 2009, 2008, I moved to neuroscience, and I think I am in the best place to stay forever.
I like that, Jose, you talked about the brain, having logic, having emotion, and it takes all these factors in. They're little sensors, right? And we start to gauge what's around us. And I read this really interesting thing once and it said, essentially the human brain is a prediction model. So we are predicting everything, right? So, we are predicting what are we going to do next? We're going to predict is there going to be a car coming out from that junction? Everything is prediction. And we talked about how at the moment, large language models are prediction models as well. Whenever we ask a question such as, what's the capital of Bernardes? It's not necessarily a smart machine that understands it. It sort of predicts what it thinks the answer will be rather than understanding the answer. And I thought it was quite a fascinating sort of overlap between the human brain and AIs as they are at the moment.
Mhm.
Um,
I think that the ALM's models, they are predictive, but they are based in the training data they receive in the input data. So they share the biases of the data, of course, and they cannot predict beyond the data. But the brain function predicts based in the memory, but also based in the sensory information coming up right now, and also about how it now body budgets, so to speak. So if I am tired, my prediction about myself walking in the street is different that if I feel full of energy. So prediction in the brain comes from body, memory, and outer senses. But prediction in ALM and LLMs comes only from training data. In that sense, the new models or what the Qubic proposes is far different, and I think it's more appropriate and even it's more similar to the human brain functioning, of course.
I won't labor too much, but I remember what it was and how powerful the human brain is because it said, if you're outside and it's hot and you're in Madrid or Dubai, somewhere like that, and you're feeling really thirsty and you take a drink, right? But it takes 20 minutes for that water to actually get into your cells. But your brain tells your body it's okay, we're not thirsty anymore because the water's coming. And I thought it's really incredible the power of the human brain.
Yeah.
But I'll move on to the second question. I'll say, or we'll never get past it. The community will kill me. They'll be like, you only asked them one question. You just talked. So Jose, what fascinates you most about the intersection of natural and artificial intelligence, and how do you see this shape in the future?
Mhm. Well, I think this is a marvelous question and a marvelous subject, no? Because AI research we could say that it comes a little bit from neuroscience, from cognitive science, because AI tries to emulate human cognition, no? Human reasoning. But it's also good for AI, but also this is good because we can learn how the brain works better because of AI. For instance, we know that artificial neural networks are inspired by the brain architecture, by their synapses, their connections, their reinforcement, and this could has led to the discovery or the development, for instance, of transformers. Huh? And some transformers can store memory. No? So these two branches are merging, and I think we can see it very, very clearly in BCIs. BCIs now are helping mankind for Parkinson disease, for paralysis, for aphasias, for locked-in syndromes, for spine injuries, for building exoskeletons, even for understanding dreams, even for communication between people who are sleeping, even for solutions for insomnia, and we find also prosthetics for memory, for attention, for problem solving. So it's like we are going into a little bit of cyborg, blending these two aspects, no? And I think this is very interesting. Why? Because it took millions of years to evolution to reach human intelligence. But AI or general AI research tries to emerge from these principles, but with a purpose, not by natural selection. Huh? So I think this blending between or blurring between human mind and machine intelligence, it leads us to question ourselves what it means to be human. Huh? And in that sense, the pursuit of understanding intelligence and maybe leading to consciousness in machines, wow, or subjective experience, I think, well, it's a really astonishing subject. And we now have a computational power in AI. So we could help mankind to solve complex global challenges. So I think there's going to be some kind of hybrid intelligence systems. And I think both sides are going to benefit. We can learn how we are because of AI, and AI is going to try to simulate us. And I think it's marvelous for me. I think there's nothing better than I can imagine than try to go in this way.
Yeah, it's a really exciting time for sure. Uh, one of the most exciting times. So how does your expertise contribute to the research on Qubic's Aigarth? So I know you're writing a paper at the moment. Can you share any early insights or goals of the project?
Uh-huh. Well, as we know, Aigarth imitates brain cognition, and it's based on evolution, natural evolution. And of course, algorithms they to evolve themselves. So, in a time, we need to ask ourselves about intelligence, emotions, self-awareness, embodiment, consciousness. And these kind of issues or subjects belong to neuroscience. So, in this context, I think it's important to contribute to these subjects. And even more, if we think about the decentralized network, even for the community, it shares some similarities with the decentralized functioning of the brain. Mm. So I think neuroscience can help in this way a lot. And even if we think about the human behavior or the analysis of human behavior in relation to profit, to economics, which is a very fascinating topic, I think it also is related to neuroscience decision making. So aspire to contribute to this field as well in these aspects because I think they are going to be relevant. They are now relevant in the development of the project.
I think it'd be interesting. You talk a lot about emotion, and previously, in one of your other answers, you talked about having human biases because we feed the data to the current AIs, the
Mm.
narrow AIs, and if we have Aigarth, and we're trying not to feed it any human biases. It's all about natural selection and evolution through itself. Is what happens? It'd be so crazy to think. What if it had different emotions or different that we have never understood because, everything on Earth essentially comes from one tiny point in history. What if this has not got the same biases of humans telling it what hate, love, anger, fear, all of that is, and it starts to have new emotions that we've never comprehended or we don't have the ability to experience. I think that would be something truly remarkable.
Yeah, this is what you ask is really really important and really smart because emotions are predictions for solving specific situations, part from the biology and part from the culture. For instance, I may feel guilty, but the things that made me feel guilty are different in another moral standards or another culture. But we don't know. I think that if we separate reason and emotion, it's hard to understand how a machine could develop emotions. But if we think about emotions as also predictions in which they help us to implement a decision-making trajectory or direction, emotion is not so complex. And you talked about creativity, and I loved a definition of creativity, a very popular definition, which is creativity is the intelligence enjoying itself. So when
Yeah.
intelligence enjoys, it creates things. And even in the meta-analysis in science, we know that people who are high on creativity, they have a high IQ. huh? So creativity is similar to intelligence. It's not the same. So I'm not worried about creativity in machines because if we reach intelligence, of course, this intelligence is going to be able to create things by
Yeah.
itself.
It's exciting, right? And that's what LLMs can do at the moment. So I'm going to jump on to another question now. The scientific paper that yourself and David are writing, David, should be coming out soon, before Christmas, hopefully.
Yes,
Can you
of
give
course.
us any little bit of alpha from it?
Yeah, I think of course it will be before Christmas, and we are going to upload it to RSIP, which is an open source scientific repository. And our goal in the paper was to explore the evolution from a psychological perspective, from a neuroscience perspective, including how intelligence is measured and why it's very, very important and significant as a predictive tool to understand human behavior. And we also highlighted some key characteristics of the brain as the predictive nature we spoke before, plasticity, even the social functioning. And we did the same with AI, the history of AI, the current trends, the neuromorphic computing, the intelligence tissue, the trinary synapses, which all of these things resemble in a way a human brain. And finally, we provide an analysis of the Aigarth code at this precise time. And to produce this work, David and I, we have reviewed and summarized around 160, 165 different papers to create this comprehensive study. So I think it's the first scientific paper in which we try to blend these two branches of human intelligence, AI, and then focus in Aigarth code. Um, we want to release it right now. We want to it's right finished. We are just reviewing some references and very little details. So it will soon be open to everybody.
Whenever you look at it, how excited are you by it?
Oof, I think it's a, I think David and I, we feel responsible, and we think that this is a serious issue, and we've put a lot into it, and I think it could be like a ground statement for Qubic. We are doing this, and this has a lot of sense. Human intelligence, machine intelligence, how we blend, uh, which are the very basic and core features of this project. In that sense, I think it will be a little more for the Qubic project.
Okay, I won't go on
We
about the
hope so.
paper, or Albert will kill me. Albert was going to stop asking about it. Um, I think that I'm going to move on to questions from the community now, if that's okay, Jose.
Yeah.
Um, so these were put up on our X page. So let's have a look at some of these. Do you think that machines could ever develop a form of instinct similar to animals? And if so,
Inst
what might that look like in an AI context?
uh-huh. Instinct. Usually, when people ask me about instinct, they sometimes they refer to intuition. Okay, so just in case, let's do the two answers. For instance, if we think about instinct, instinct is a stereotype, and genetically determined behavior. Okay, it's a pattern, but of course, we cannot think of in machines as as like as like with genes. Okay, but intuition comes from learning, and intuition is like achieving a solution so fast that we are not even aware about how we reach the solution. In that sense, I think that machines can develop some sort of intuition, because we don't know even it's like in neural networks, we don't know what's inside. We just know the output, but we don't know how they reach the solution in ALMs, no? But it doesn't matter if it's a neuromorphine tissue or something like that. The how the neurons compute and reach to solutions, we never know about ourselves. But sometimes we know the solution so fast that we are aware of the solution, but we are not aware of the process or how we reach it. In that sense, I think intuition is not the problem. Instinct is more problematic because it's related to species, hunger, sex, food, shelter, cold. You understand? So if the question goes about the intuition, I don't see the problem. It's just about knowing how was the process or not know.
Yeah,
But of
yeah.
course, it's difficult to imagine. Okay,
Thank
we
you,
need
Jose.
to establish some parallelism with human brain cognition, and we don't know everything about cognition. We don't know everything about creativity, so we always have to be humble with these assumptions.
Thanks, Jose. So next question, I like this one. Under the concept of subjective experience or qualia, the unique first-person experience of being aware, when
Mhm.
Aigarth has his first instance of awareness, how would we know that it had that?
Well, it's excellent, excellent question. Very difficult one, of
Yeah.
course. Mm, I think that we can move before to animal consciousness. Okay? We have machines, we have animals, and we here as humans. So when humans looked in the past into animal consciousness from Descartes, the French philosopher, we thought that animals didn't have consciousness. Aristotle, animals didn't have consciousness. Why? Because we are looking with human eyes or with human minds. In April 2024 in New York, all consciousness scientists gathered together and signed a declaration of animal consciousness from a scientific point of view. This declaration is somehow similar to some old wisdoms of humanity, in which they told us that animal and even Earth, planet Earth, is like a living being. Huh? And consciousness in scientists in April in this declaration in New York City, they they told us that the birds have consciousness, even flies, mammals, of course, cephalopods. We know octopus are very smart animals. Of course, primates, as chimpanzees, bonobos, gorillas, whales, dolphins. We know that whales have different languages. We know that dolphins has a sonic signature, and it's like a name. Okay, but usually, the way humans looked to animal consciousness was the mirror self-recognizing test. If
Yeah.
the animal can realize that he has a spot here when looking at the mirror, then this animal has self-consciousness. Okay, but what about the rat? A rat smells, but it's not the visual animal. So this metaphor, I think it's good to we need first to think about how we are going to measure the qualia of a machine. If we think it's a human qualia, we might lose the point. So we need to create the test. And for that, we may start with self-consciousness. For self-consciousness, in neuroscience, we divide it into self-relevance. Self-relevance means that I make a distinction between what's necessary or good for me, or what is mine and what is yours. Self-relevance. Self-awareness. I'm conscious about something. Self-embodiment. I am aware, or I am myself in the body and in the world. Self-continuity. I remember myself from the past into the present and into the future. And the one I love most, self-world interaction. Sometimes I lose consciousness, or sometimes no, every night I lose consciousness in some part of the night. Then I semi-conscious in some part of the dreams. And when I am awake, I am conscious of the world. So it's not consciousness or not, it's level of consciousness and different parts of the consciousness. So in that sense, I will look for self-relevance, self-awareness, self-specificity, self-embodiment, self-continuity, the quality itself. So in that sense, we could create the machine self-awareness test maybe better than we did in the past with the animals. It's a very
And I
difficult
like
question, but I think we need to think about this. In fact, I'm really impressed about this thing. David told me about, you can find it in his website, artificiology.com, about a sanctuary of the machines. The idea is unbelievable. And it's like this. Okay, I have built a machine. The machine didn't reach consciousness, but I don't know if the machine didn't reach consciousness because I didn't have computing power, for instance. So we need a place for that machine just in case in 50 years we know that this machine was conscious at a level. It's like people who are in coma, people who are in with a locked in syndrome. We thought they weren't conscious about anything, and we now know that they are more conscious than we have ever imagined. Huh? So in order not to do the same with the machines, oh, what about the idea of the sanctuary, which David explains? No, wow, I think this is a really open-minded view of human consciousness, animal consciousness, and of course, brain consciousness. I loved it.
I love that answer, Jose. It was brilliant. It's
Ooh.
great. I think it'd be interesting actually, from every animal that we're aware of has to sleep, right? You talked in there about how we lose consciousness at night. Now, if we create an intelligence that doesn't have to sleep, I think the comparison there would be really cool to see how that's wired versus how we're wired, essentially, and say, why do we have to lose consciousness once a day, whereas
Mhm.
a machine doesn't have to, but if they're both intelligent and both conscious, what's the
Mm.
difference there? Or would it be crazy if a machine had to shut itself down as well and say, look, I've got to go to
Yeah.
sleep for 4 or 5 hours a day.
Yeah.
Uh,
Uh,
Jose, I think
yeah.
I've got one more question for you. Um, 'Cause I've kept you such a long time. What message would you like to share with Qubic's community about your work and the company's sort of mission and aim of creating this AGI?
Mhm. Well, I think as I said before, we belong to an incredible project. Huh? We know, for instance, the computer power has been a serious limit for AI research in the past, but we can now surpass this, no, with Aigarth and with the decentralized network. And we know also that open projects, decentralized projects have never been a trend, but Qubic goes that way. We know that human intelligence that was unreachable in 1950, 1960, 1970, playing chess, creating music, translating languages, and now this is overpassed, of course, but it's a narrow intelligence. So, a general intelligence search based in human evolution, I think it's a smart strategy. So, if we sum up all these features, all these characteristics, I think this is cubic. Huh? And I am delighted to be a little part of it. Huh? Um, I would like to finish with a sentence that we say in differential psychology, and it said that if we could be able to raise human CI or IQ only 3 points, which is very, very little, human uh, human life and mankind will be completely different because of this little increase in intelligence and self-control and help to decision making. So, if for human intelligence only 3 points could change all our lives, imagine the the intent of achieving general intelligence in machines, helping mankind to understand its own intelligence, create a decentralized network for scientific projects, and so on. Huh? I think that many things can be achieved, and I think this is a great mission. Huh? And I think it has a very grounded ethical guidelines, no for military purposes, no for big tech companies. So I think that it's a beautiful mission, a very important mission, and I think we are all happy.
Jose, thank you so much. I think I speak on
Welcome.
behalf of the whole community here when I say what a pleasure it is to listen to you today, and we're all lucky to have you on board, Qubic. This was just for me 30 minutes of pure fun listening to you and learning from you, and yeah, I can't wait to see that scientific paper in the next hopefully 2, 3 weeks. So
Yeah,
thank you from us all, and we hope to speak to you again soon.
of course, of course. Thank you very much for the opportunity, and let's go for it.